We're now going to talk about functions, the nitty-gritty of functions. So a function is really just a rule. It's a rule that takes in inputs and gives out an output. Predictable means that for any specific input, you can only have one output. For each thing you put into the equation, there's only one possible result. So you've already been working with functions, they just haven't used function notation. For instance, if we look here, this is your first example of a function. The way we read it is f of x equals 3x minus 5. The left side, we don't do any calculating with this side. There's nothing to do. It's just a placeholder. And in fact, in the past, what we've used there is y. You might have seen equations like this. Y equals 3x minus 5. Well, all we've done here is replace y with f of x. We've given the equation a name, and its name is f, and the of x part means, hey, x is going to be our input. We're going to put something in for x, and we're going to times it by 3 and subtract 5. One of the reasons mathematicians resorted to function notation is so that they could talk about multiple equations at once. Let's say you had three equations. Y equals this one, 3x minus 5. How about y equals 2x and y equals x squared minus 1. And you wanted to do different things with these equations, like try different inputs in them. And you wanted to write up a set of directions. Perhaps you're a teacher. Maybe you wanted someone to put in 0 for x in this equation, put negative 1 in for x in this equation, and put 5 in for x in this equation. You'd have to say the whole equation out loud so people would know what you're talking about. But if you call this one f of x equals 3x minus 5, and you call this one g of x equals 2x, and you call this one h of x equals x squared minus 1, then you can quickly tell somebody, hey, in f of x, put in a 0 for x. In h of x, find x when h of x is 10, and so on and so forth. So this is just a way of keeping equations straight. Give them a name. Replace y with this function notation. All right, and one other thing about functions is this idea that for each input there's only one output. For instance, if I tell you to replace x with 2, use the input 2 in this function, you're only going to get one possible answer. You're going to go 3 times 2 is 6, subtract 5 is 1. There's no other possible answer for the input 2. Likewise, there's no other possible answer for any input. So that's one thing that makes it a function. So a couple of reminders when you're working with functions and function notation. The f, it's not a variable. It's not multiplying by x. This doesn't mean f times x. It means f of x. It's just a name and a placeholder for what you're going to put into the function. F is the name for the function. The reason we name the function is so that we can have differentiate between other functions we might also be considering, such as the example over here. X is the input for the function. Whatever's in that spot, whatever you put in for x is the input. 3x minus 5 in this case is the output. It's what you get once you put the input in here, times it by 3 and subtract 5. That will be the output part of your function. And it changes depending upon your input. If I put in 1 for x, 1 times 3 minus 5, 1 times 3 is 3, subtract 5, it's negative 2. For the input 1, I get a different output. All right, let's move on and look at a specific function. We actually have two of them here. We have f of x and g of x. F of x is 4x squared minus x plus 7. And our other equation, which we've named g of x, is negative 3x plus 10. Let's look at what the notation means. We're going to be putting in 3 into the f function for x. So that means if I see this, it's telling me that I need to find the function of 3 in this equation, the one that's labeled f. In the second example, g of 2t plus 1, I'm being told that wherever there is an x in this function, I'm going to put the variable expression 2t plus 1. And in the next video, I'll show you how to do just that.